In this tutorial, I'll show you how to graph piecewise functions. I have 3 examples set up for you. Let's begin with question A. As you can see, the function for question A is an absolute. We have these absolutes around x, and what that means is that you'll have a positive x and also a negative x. The positive x is for x values that are greater or equal to 0, and the negative x is for x values that are less than 0. So keep that in mind. If we want to graph this one right here, that's like graphing the function f of x is equal to x. And just from experience alone, I know that this begins at the origin and it goes up 1 over 1, up 1 over 1. That is, if these are intervals of 1. So to graph this one, I'll put a line going diagonal starting from the origin. What you see right there in red represents x. For negative x, we have x values that are less than 0. So we'll be focusing on this side of the xy plane, and if this is for positive x, then for negative x it should be the opposite. So our graph should look like this. That's the answer to question A. Let's move on to question B. In question B, we have 2 parts of the function, one being x squared, and that's for values that are less than 1, and another part, 1 minus x, for values greater or equal to 1. Let's begin with x to the power of 2. That's another familiar expression that we know. X to the power of 2 gives you a parabola facing upwards. So I'm only going to sketch it. I'm not going to show you a perfect representation of x to the power of 2, but it should look like this. So this is x is equal to 1. Therefore, our parabola should look something like that, where it stops at x is equal to 1, and I'll put a hollow circle to represent that it cannot equal to 1. Then, when x is greater or equal to 1, we have 1 minus x. 1 minus x is a first degree equation. Think of y is equal to 1 minus x. This would be your y-intercept, and your slope would be this part right here, where you have negative 1 over 1 technically, because that's a negative 1 and you can represent any integer over 1. This is your rise and your run. A negative slope tells us that the graph will be going down to the right starting at the y-intercept. Our y-intercept, being 1, is right here. And because we're dealing with values that are greater or equal to 1, we will start right here, and it will go down 1 over 1. Down, over, and you would have a straight line going like this. Let me show you what that would look like. Of course, you would put a solid circle right there to represent that that's where it begins at x is equal to 1. Moving on to our last example, we have 3 parts to this piecewise function. In the very first part, we have a linear equation, and then we have the number 2. If you have y is equal to 2, for example, that will be a horizontal line crossing 2. And that happens between negative 2 and positive 1. And lastly, after x is equal to 1, we have another linear equation. Let's begin with negative 3x minus 6. So let me write it down for you in equation form. Y is equal to negative 3x minus 6. That is going to be our slope at negative 3 over 1. That's our y-intercept. So our y-intercept is at negative 6, 1, 2, 3, 4, 5, 6. And because our slope is negative, we go down 3 over 1. So we should have a line, not taking into account the restrictions for now, we should have a line that looks something like this. And remember, that only happens between negative 3 and negative 2. That's negative 1, negative 2, and negative 3. I'll put a hollow circle there and a hollow circle here, and everything else I will erase. That represents that first equation. As mentioned earlier, negative 2 will be a vertical line at the y-axis between negative 2, and it has to be negative 2 because we have less than or equal to x and less than or equal to 1. So this is 1, 2. We'll have a line that extends from negative 2 to positive 1. Notice the whole circles as opposed to the hollow ones we used earlier. And for this equation, y is equal to negative x plus 2. That's our y-intercept. Our y-intercept is at 2, so over here, but we have to start after x is equal to 1 because of our restriction. Let's just pretend that we didn't have any restrictions and we were graphing it normally. our slope would be negative 1 over 1. So starting over here, down 1 over 1, down 1 over 1, and so on. This is what it would look like. Because we have to start after x is equal to 1, I'll put a hollow circle right there and connect these dots. And of course, it would just continue like that. And there you have it. That is how to graph piecewise functions.